Hi, today's topic would be function notation. So we've seen so many functions like fraction, such as x minus 2 squared over 10 minus y plus 4 cubed over 5 equals to 2. This is fraction. We've seen quadratic function, x squared minus 2x plus 4 equals to y. And radical function, square root of x plus 3 equals to y plus 7, or even linear equation. So in general, x is the variable that we plug into this function or in this equation. And we evaluate and try to find the value of y. So in a word, S is the input, we put something in it, and then Y is the output. So that is the equation. Okay, so there's multiple ways to represent a function. We have a table, we have an equation, we have a graph. Now let me give you some examples, such as table. We have a table X and Y. They have a different value. If we put in 1 in X, the corresponding y is 5. If we put in 3, corresponding y would be maybe 9. If we put in 4, the corresponding y would be maybe 12. Okay, so this is one way to represent a function. The second way would be graph. So we have a graph in here. So in this graph, this point is 0, 0. That means when x equals to 0, y equals to 0. So let's say if this, the peak of this graph, if y is 2, x is negative 3, so that means if we put in negative 3 into that graph, this equation, the output value would be 2. Or if we put in x, x4, and then the output value would be 0. Okay, so the third way to represent a function would be an equation, such as fx equals to 4x plus 3. This is equation also represent a function, such as f of 1 means we substitute x equals to 1 into the equation. So we have 4 times 1 plus 3, which is 7. So in here, we have x, right? So now we replace x, we replace 1 with every x. Okay. Now, how do we know that if I give you an equation or I give you a graph, how do you know that, hey, this graph is a function, the other graph is not a function? So we have a vertical line test. So the vertical line test states that a vertical line intersects with the function more than 1 point, then this graph is not a function. Okay, in here, the keyword is more than 1 point. Since it's a vertical line test, that means we need to have a vertical line. So here is some examples. So, let me use a blue one. So look, this is the graph, right? It goes down and up and then down and then goes up. Okay, so when you look at this graph, you find a vertical line. Look at my ruler. I keep pushing from the left to the right. The ruler always have 1 point intersect with the function, right? We couldn't find the ruler intersect with the function more than 1 point. So that means this is a function. Because when we find a random point, random line, look. And then you just intersect with this graph with 1 point. So this is a function. So now let's look at another example. Oh. So now look at this graph. Again, we have a vertical line. Look at the ruler. Right now, the ruler intersect with the graph with 1 point, right? Still 1 point until here at this part. There's a vertical line intersect with the function with more than 1 point. And then as we go left, the ruler keep intersect with the function with more than 1 point. Sometimes it's 2 points, sometimes it's 3 points. It doesn't matter. As long as you can find one line, we just need one line and then intersect with the function with more than 1 point, intersect with the graph, I'm sorry. So we can say this is not a function. So if you look at the idea of the vertical line test in algebraic method. So when it comes to a relationship of a function y and x, what happened? For example, if here is x equals to -2, and this is x equals to -4, and let's say, if we have this line, which is x equals to -6. So when x equals to -6, y only have one value, right? We only have one y. But if x equals to -4, look at the second line, there is how many y value? X can equals to, look at my yellow point, you will have 2 y value, right? So that means you will have 2 solutions for y. And then when x equals to 2, you have what? 3 solutions for y. So, but when you look at the graph, which is satisfied or passed the vertical line test, which is our left one, each x value only corresponding with one y value. And then this type of graph is a function. So that means, in a word, if we want this to be a function, we want each x value only have one y value. Okay, let's use this to prove is x squared minus y equals to 5 a function. Well, if we can solve for y with one solution, then this is a function. So now let's solve it. We add y on both sides. We have 3x squared equals to y plus 5, and then we subtract 5 on both sides. We have 3x squared minus 5 equals to y. Look, we only have one y. We only have one solution for y. So yes, this is a function. Okay, let me show you an example that when it is not a function, when the equation is not a function. So look, when it comes to y squared minus x equals to 5, is this a function? Well, let's solve our y. We add x on both sides. We have 5 at x, 5 squared at x. And then what? We take square root on both sides. Remember, by the square root property, we know that if you take square root on both sides, you will have a positive and negative solution. So that means these have two solutions. Either y equals to positive square root of x plus 5, or x or y equals to a negative square root of 5 plus x. So that means there's two solutions for y. So this is not a function. Okay. So now we use another notation for function. So instead writing y equals to some equation, we write it as fx equals to some equation. So let's look at our previous example. So in here, we know that this is a function. We don't want to write this as y, we want to write it as fx. So the function notation should be fx equals to 3x squared minus 5. These two are equal. You can just think about fx equals to y. You can think about it that way. Okay. So now let's consider domain. The third definition we're going to learn is domain. So domain is the set of all the possible value of what? Of x. Okay. So let's look at the most basic, the easiest, the simplest radical function. Fx equals to square root of x. Okay, so now let's look at all the possible value of x. X can be 0, right? Because square root of 0 equals to 0. X can be 1. Square root of 1 is equals to 1. And then, okay, let me write it here. Then fx equals to square root of 1, which is equals to 1. Or x can equals to 4. So square root, excuse me. So square root of 4 equals to 2. So that means x can equals to 4. Even when x equals to 2, okay, it's not those perfect square. We might not know the answer right away. But when you plug into a calculator, they won't tell you that, hey, this is an error. It's equal to 1.2 something or 1.1 something. I don't really remember. When you plug into a calculator, it tells you the answer. Even you can write x equals to 2.5. You will still have the solution with a really long decimal. So that means x can be any positive number. So now let's think about, can x be negative 2? Well, if you plug in x equals to negative 2, you will find out that, hey, there is an error. It doesn't exist. Or you plug in x equals to negative 4. Well, this is not equals to square root of negative 4. This is not equals to -2. If you don't trust me, you can just plug in this into calculator. Okay, so that means what? When we summarize this, we find the pattern. So what do we know? We know that x equals to can be equals to 0. X can equal to any positive number, but x cannot equals to negative number, right? So this is the domain of the function. In the word, we say, hey, you can put a negative number under the square roots. Okay, so the domain should be, if you can put in a negative number into the square root, so the domain should be x greater than or equals to 0. Or you can write into an interval form, which is x is including 0, so it's a bracket, to infinity. Okay, now let's look at this example. Fx equals to 3x minus 1 over x squared plus x minus 6. So this is a fraction equation, right? Fractional equation. So with this equation, when you take a look, what do you think? Well, since it's a fractional equation, we know that the denominator, the blue coated one, they can be 0. Okay, so so we have x squared plus x minus 6 not equals to 0. And then we solve that and find out what x cannot be. We use AC method, and then we solve that. Hey, I'm sorry, this should be plus. Should be minus 2. Okay, so x is not equals to -3 or x not equals to 2. So that's the solution. That's the domain, so that means x can be any number. 3.5, that's fine, even -3.1, 3.99999, that still works, but x cannot equals to -3, and the x cannot equals to 2. So let's draw a number 9. So to the left would be infinity. With a 0, we have 1, 2, 3, 4, 5. To the left side is -1, -2, -3, -4, -5, and then negative infinity. So this is the number 9. Okay, so we know that there is 2 numbers that x cannot equals to. -3 and the +2. X cannot equals to these 2 numbers. Other than that, x is totally fine. That means you want x equals to anything on my blue highlighted part. So how do we represent this part? Well, it has 3 parts, right? The first part, the second part, and the third part. The first part is from -infinity to -3, not including -3, because you can't equal to -3. Union -3 to 2, union 2 to infinity. So this is the domain for this equation. X is inside this interval, any number. They can be any number inside this interval. Okay, so if I ask you to find the domain of fx equals to 3x squared minus x. Well, we know that this is a quadratic function. This is a quadratic equation. And when you look at this equation, we know that there is no restriction on x. X can be a negative number, x can be a positive number, x can be 0, x can be any number. So that means x is in all the real numbers. This notation means all the real number. So that's the domain of this function. Okay, what about a radical function? Now I want you to find the domain of square root of 3x minus 3 for me. Well, when it comes to square root, you think about the most basic square root. We just talked about that at the beginning, that everything under the square root, you can put a negative number under the square root, right? So now let's take a look. What's under the square root? 3x minus 3. You can put a negative number in there. So that means everything with the green coated one has to be greater than or equals to 0. It has to be positive number or equals to 0. And then we solve it. We have 3x greater than or equals to 3. We add 3 on both sides. And then we divide it by 3. Since we divided a positive number, we don't need to flip the sign. Remember, if you divided a negative number, you have to flip the sign. So x is greater than or equals to 1. So this is the domain of this equation. You can write it as equals to 1 to infinity. Okay, now how do we evaluate a function? Okay, if you were given fx equals to 3x squared minus 4x, and you need to find f of negative 2. What's this notation mean? X equals to negative 2. You can think about that. Well, y equals to 3x minus 4x. Remember, fx equals to y. F of negative 2 means x equals to negative 2. Because look, inside the parentheses means x. So here inside the parenthesis now is equals to 2. That means x equals to negative 2. So y is equals to 3 times negative 2 squared minus 4 times negative 2. So it would be 12 at 8 equals to 20. So that means when x equals to negative 2, y equals to 20. But we don't write it in this way now. We write most simplest way. We write f of negative 2 equals to 3 times negative 2 squared minus 4 times negative 2, which is equals to 20. So that means you don't, if you're really familiar with what's fx, you don't even need to write this part. We can just skip it, skip this line and just go to, hey, f of negative 2 equals to, we substitute x equals to negative 2 into the equation to find the value of y. Okay. Sometimes they use different notation. H of x equals to 3 to the 2x minus 6 power. And they want you to find h of 4. Again, this is also asks you when x equals to 4, h is equals to what? So we have h of 4. You want to substitute x equals to 4 into the equation. So with 3 to the 2 times 4 minus 6. Look, we just substitute this x, become 4 into the equation. Okay, so we have 3 to the 2 times is 2, which is 3 squared is equals to 9. So h of 4 equals to 9. Or they will use k of a, which is 2 times a plus 4, and they want you to find k of negative 7. Well, it doesn't matter. They just changed the number, the letters, but that represent the same thing. This means the function with an input value A. That's what that means. Whatever inside the parentheses would be an input value or independent variable. So this part is A, and we want to change it to -7. So that means k of -7 equals to 2 times A, going to change to -7 plus 4. This is equal to absolute value of -3. Absolute value of -3 is equal to 3. 2 times 3 is equals to 6. Okay, so what if a little bit more complicated one? If we have g of x equals to x4 plus 1, and then you need to find g of 3x. Okay, what to do this one? Well, that means instead of replacing a real number, you want to replace in 3x for every x. Okay, so let's look at the equation. We have 1x here. This x is going to replace with 3x. So that I have g of 3x equals to 3x to the 4th plus 1. Is this true? No, you need to put a parenthesis here because whenever you replace the x, you want to put a parenthesis with the part that you replace. Why is that? If you don't put a parenthesis, you may just convince yourself that, hey, this is just equals to 3 times x to the 4th. But actually, the exponent also raised full power to the 3. So I have 3 to the 4th, which is 81 x to the 4th plus 1. Okay, now let's do a way more complicated one, the last example. So if I have p to the t equals to t squared minus t, how many t in the equation? So we know that inside the parentheses is a t, so that means this equation is about an input value of t. Okay, so we have a 2t here. That means we want to replace this 2t if we need to replace anything. So pt of a equals to what? So I replace all the t with a. Now we simplify. P of a is equals to a squared minus a. What if I ask you p of t plus 1? So that means what? Look, the parentheses was replaced by t plus 1. So that means everything with t, this part is going to replace by t plus 1. This part also replaced by t plus 1. So with t plus 1, again, don't forget the parentheses, minus t plus 1. Well, this is a perfect square trinomial. So I have square plus 2t plus 1 minus t minus 1. Don't forget a negative sign is going to change the sign inside of the parentheses. We simplify it. So I have a t squared plus t. So this is equals to t of t plus 1. Okay, you need to do more exercise to understanding what's that mean, how to evaluate if the how to evaluate the function if the input is not just a algebra. What if the input is a letter or the input is another function? We'll talk more about that in next time.